Okay, this is I convert to the pictures. The document that I sent to you in the review packet, I copy and paste into the whiteboard. Do you see clear? Question one. Well, question one is graphic. Graphic. I want to copy here. Graphic. The function exponential, of course. F of x equal 2 to the minus x. And remember, negative exponent is reciprocal. This is equivalent to say 1/2 raised to the x. Because 2 to the negative 1 is 1/2. Okay, now we have exponential, but the base of the exponential is 1/2. And when the base is less than 1, we have exponential decay. And the graph is super easy. Remember the classical 3 points. The first point is the point 0,1. This is universal in any exponential. The second is 1, the same value of the answer. So we have 0,1, it's universal. We have 1,2, because when you raise to the 1 power, it is invisible. And 1/2, so 1/2 look like here, approximately 1,1/2. And another point is -1. So this is the classical point, guys. 0, 1, and -1. And -1 is reciprocal. And reciprocal is 2. You flip it. 1/2 flip it is 2. 2 over 1 is 2. So -1, 2 is this. Okay, you can plot more points. Yes, if you want, but no. Enough 3 points. It's a -1,2. And you connecting this by the curve. I know what kind of curve. I know also important. Okay, any exponential, for example, -2 to the 4. Exponential out. Exponential. Well, I try to do my best by hand. Okay, something like that. Important information is any graph of the exponential have one horizontal asymptote at y equals 0. Horizontal asymptote at y equals 0. End the story. We finished question 1. Any question, guys? And then you see that you have one exponential graphic. I don't know if the base is greater than 1 or less than 1. Let's do in the second. The second is similar, but the only difference in the second is that the base is 4. No? The base is 4. So the second function is do you understand very well or no? Let me know, please. Answer me, please.
Yes, we understand.
Yes, Professor.
Okay. Now again, same idea. The universal 0,1 point, I plot that. We have 1 comma something, in this case 4, because the base is 4. 1,4, 1, 2, 3, 4. This point is 1,4. And -1, case 1 over 4, 1/4. Okay, using our imagination is half of the half, approximately that pound. This is the point, -1,114. Okay, so we have 3 points. The exponential look like that. Remember, one more clue. The exponential is growth exponential, so increasing. So when you're moving from left to right, the y value goes up. In this case, when you're moving from left to right, the y value goes down because it's decreasing, but this is increasing. And don't forget, please, it's an important piece of information. The famous horizontal asymptote at y equals 0. End the story. I don't know. You need to realize if our problem is decay or growth. That depends on the base. When the base is less than 1, it's decay. When the base is greater than 1, it's growth. Any question, guy? No? Super clear? Sure? Okay.
Yes.
Okay, let me try to erase the board, at least that part of the graph. Let me try. Okay, that part. Okay, delete. Oh, the graph is also delete. Let's focus on the question 3, because 3 and 4 is a word problem. I want to explain everything in detail. Please pay attention. And number 4 is a hypothetical problem in which talking about a population. So the growth in the population fit the exponential function is given. Okay, I appreciate so much. Number 3 is given the function. Population at any time is equal 346 E. Remember the E is the famous base of the natural logarithm, is an upper number, and the exponent is 0.05 t. T represents, I suppose, que the time. Entonces, what t, where t is the number of years since 1978. So basically, let me try to make a picture. I like that. I don't know why. To understand the problem. This is the time, and this is the population. At any time. At t equals 0. Okay, by the way, in our supposition in the problem is 1978 is 0. The population is 346, because that number. That number is initial population, always. Now I know the base is greater than 1, therefore this is exponential growth. Because I need to investigate what's going on in 2011, no? 2011. Okay, this is the thing I want to find. What is the population in 2011? Question mark. Okay, so I put in my calculator immediately. I subtracting 2011 minus 1978. How many years is this duration? 2011 minus 1978. Boom, it's 33 years. Actually, this is, you suppose that this is 0 year and this is 33 years after. And just plugging in 33 and the t value. So basically, the thing that the problem 1 that you find was, is p evaluating 33. Entonces 346 equals 0.05 multiplication by 33. As always, guys, I want to explain in my virtual online calculator. And I appreciate so much. Can you double checking in your own calculator, see everything is okay or not? Okay, and give me the answer. So I want to copy one piece of paper, 346 times exponential, and the exponent is 0.05 multiplication by 33. Okay, cool. I open my calculator. Let me try to do my best. You let me know. I want to share this screen, and you let me know if you see or not. Do you see?
Yes.
Well, just I put 346 multiplication time here, time. Exponential, and this virtual calculator exponential function is located in the function that kind exponential e to the x. In the exponent, I put 0.05 times 33. No mistake. In the same exponent. Let me try to do my best. Time. No. Well, I put the parentheses maybe. Let me try. I open the parentheses maybe. Inside the parentheses, I copy 0.05 times 33. Because this belongs to the exponent, no? And the answer is 1,801.62. 62, this is the, I don't know what kind of population it is, but it's a population. So the answer then is, let me know if you get the same answer like me or not. Let me double check in my calculator. I have my calculator by hand. Is 346 times exponential. Where is exponential? I saw. And the exponent I put 0.05 times 33. And get the same answer. Beautiful. The answer is 1,801.62. I don't know. Yes, people, the decimal have no sense, no? But it's okay. I copy because the convention and the text. Say again. I don't understand very well. Come on, try to speak something. Nobody? All right. My question was, you get the same answer like me? Yes or no?
I didn't get the same answer. I'm not sure if I put it wrong in my calculator, but I used the EX and I got 173.268.
No good. Okay. In any calculator, miss, you have one key, que es LN. Do you see in your calculator?
LN?
Yeah. Do you see?
Yes.
Entonces, en the same key, in another color, in the calculator I have in this moment in my hand, is yellow. You see e to the x. You see in the same key, you see e to the x. Yes or no?
Yes. Yes.
So I want to guide you. Okay. You typing 346.
Yes.
Multiplication time.
Yes.
Multiplication sign. But let me try to do simultaneous and the other calculator. 3, 4, 6 times. Now you press one key, que maybe is second, and my calculator is yellow. You press second and you select the same key of the LM, but actually it's no LM.
It's log?
Yeah.
Oh, exponential.
But when you press second, this key have two functions.
Yes.
Entonces you select the function in yellow color, que es exponential. Got it?
Yes.
Cool. Now the only thing you should do is put inside the parentheses 0.05 time again multiplication 3 and close the parenthesis, please, and press enter.
Yes. Thank you.
No
problem. I got the same answer.
Okay. I recommend you practice by yourself this, okay?
No problem. Thank you.
Okay, so now I come back to the whiteboard. Let me see. Whiteboard. My final answer is P at 33 years, actually is 2011, is 1,801 and 62. Remember the convention. I don't know exactly what thing we are computing. Si es people. Entonces now the convention is always you round off your final answer to the near hundredth, so 2 decimal place. Okay, because next digit is 5, it's 615. So okay, cool. Everyone follow me? Cool. Yes. So I want to erase or no? Not yet. 1, 2, 3. Erase, no? Boom. Okay, number 4 look like a little bit more complicated. It's a finance morning, the finance problem. Okay, the formula, remember, was future value is equal present value, parentheses, 1 plus r over n raised to the nt. This is the compound interest formula. But the problem is that we have 2 options. So I split the paper in 2 parts. Okay, and the first option, the present value is $15,000. And the second is the same. In this case, they are perfect coincidence. However, and the time is also 10 years. Hey, Professor Alberto Abreu. Okay, I don't know why. Okay. Alberto, guy, are you aware that this test number 3 is due next Monday? By the way, is according to the calendar is 27, March 27. You have to send me the solution for this test. Okay, so the 10 year is the same, but the option A is compounding continuously, and the interest rate is 9.5%, again decimal, remember, is 0.095. Now you divide it by 100, 1 2 decimal place, you move into the left in order to convert percentage to decimal. And here is R is equal, likewise, 0.092 in decimal. But what is the difference? The compounding is different because in the option A is continuous, and continuous is different formula. Look, we have 2 formulas, future value is equal present value, exponential RT. So this is the formula that we're using in that problem. However, the formula that we are using in the second part, in the option B, is this RT, and this is future value is equal present value, parenthesis, 1 plus R over N NT. Okay, and this is semi-annually, I know very well that N is 2. And when it's continuous, no, continuous N is infinity, and the formula change to this. Okay, no problem. Right, let's do it. So this is very, very similar to the problem number 3, that was exponential. So the future value is equal to 15,000 e to the 0.095 multiplication by 10. Okay, let's do it. Okay, 15000 multiplication sign. Don't forget here, multiplication sign, time. Exponential, you know where you can find in the calculator. Okay, now inside the argument of the exponent is 0.095 times 10. Boom, yeah, I get the answer. Let me know if you have some answer. How many money you have in the future in the option A? Option A, option B. Because basically, the problem is you compare both options and you make a decision what yields the greater return. And you compare here, you want more money, no? So you select the option that you consider better. Okay. Who have the answer for the first option? And the second option is 15, exactly the same. 1 plus 0.9, 0.0, sorry, 0.092 divided by 2, because the compounding is 2, and raised to the multiplication, and t gets 20, because t is 10 and it's 2. So actually, we have 20 payment period, because 10 year, 7 annually is 6 months, is a half a year, 20 payment period. And we compute that in the calculator. Come on, guys, working in the calculator. This is part of the game, calculator. Okay. And the first one is 38,700. Yeah, you're right, mister. Mia say que 38,785 and 64 cents. Let's compute the second part. The second part is 1500,030 time parenthesis 1 plus 0.092 divided by 2 plus the parenthesis power, and the majority of calculator is the key que have that symbol. This is the power. Look like the roof of the house. Press enter. Oh, I make a mistake, mistake. What is, oh yeah, I forgot. I forgot exponent, que es 20. Okay, I have the answer, yes. Who help me with the answer? Another student, no Mia.
36,874.
Uh-huh. How many cents? 74. Sorry. You say 874. Es the dollar, no? And the cent is 40, no? I guess so. Because it's 39.8, no? So you analyze two digits, the digit after the 2, the third one is 8, greater than 5, so you increase it. 39 plus 1 is 40. Entonces, what is the best option? The option A or the option B? What option you select? Come on, this is the easy part. It's obvious que option A, no? Okay. Any question on this problem? Everyone understand very well or no?
Yeah.
Any question, any problem with the calculator, you get the same answer. This is the idea. So suppose that we have in person in the college, in the classroom. Because I go one by one student. All right, show me your answer. Show me your answer. Show me your answer. No, I don't know. Let me try to explain. It's the same thing. If you don't get the answer, because I try to help. No problema.
Nope.
Okay. It's easy, I know. Erase everything. Okay. Question 5 and 6 is again graphic, but it's graphic no of the exponentials, the logarithmic is a little bit similar, not too much, but a little bit. Let me try to find a paper. Okay, it's a paper. Okay, big graph. We have 2. Okay. And the first one is easy. So we are doing now number 5 question. Is do the graph of the logarithm base 2 of x. Okay, so you need to remember the universal point in the logarithm is 1, 0. It completed you remember the universal point and the exponential would be 0,1. But I need to know que el logaritmo is the inverse function for the exponential that you swap. I plot that. It's here. And the other I suppose is the same because this is universal. Okay, in the question 6, we are doing 6 question. Logarithm of 1/2 of x. What is the difference between this and this? This base is greater than 1, this is increasing. This base is less than 1, is decreasing. But we continue. What point you select? Oh no, you select a smart point. You select 2 and 1/2. For example, I know very well que logarithm base 2 of 2 is 1. Now this imply the point 2,1. 2,1 here, 2,1. You see? 2,1. And why not? Logarithm base 2 of 1/2, que es reciprocal of 2, is -1. Why? I know that because I know very well that 1/2 is the reciprocal. Now, what should I do in order to get reciprocal? Well, no, negative exponent. And why -1? Because it's the same. You know? If you flip it 1/2, you get 2. And the point would be 1/2, que is the middle of this segment, -1. I have 3 points. Look at that. Now ready to connecting this point. But you know 2 things. This logarithm is increasing. Okay, and this logarithm has one vertical asymptote at the line, the vertical asymptote at x equals 0. Okay, it's exactly coincident with the y-axis. Okay, this continue approach asymptotica, pero never touch. The idea for number 6 is very similar, but you apply logarithm now. Logarithm, pero 1/2. Sorry, logarithm base 1/2 or 1/2. Es obvio que 1. The same idea. See, they are perfect coincidence in between the base and the argument. The answer is 1. It's the same. It's this point. However, logarithm base 1/2 o flipped que 2 es negativo. Entonces 1/2, 1 is here. And 2, -1 is here. 2, -1. So -1 is a 2. Therefore, my graphic is decreasing. Passing through this point, this point, this point. And don't forget, please, the famous vertical asymptote que any logarithm function has at x equals 0. Boom. The only difference is that this is increasing and this is decreasing because the base is less than 1. Super cool. Everyone understand very well this? Come on, guys, this is a review. It's important that minimum thing that you don't understand, you let me know. Yeah, explain. It's my pleasure. My pleasure. Clear? Continue.
Clear.
Eso. Okay. Erase. Okay. My intention is I try to finish today the review. Let me know si es possible or not. Okay. Number 7 and number 8 is super easy because it's the conversion from, for example, let's copy ABC. 7 question 8 is logarithm base 2 of 1 over 32 is equal negative 5. Logarithm base 3 of 1 over 243 is equal negative 5. You don't need to compute anything because I suppose it's true. Don't try to check it. Don't waste the time checking. And logarithm base 2 again of the 1 over 1024 is negative 10. What is the goal? The goal is conversion. So you put an arrow here. Conversion to exponential. Conversion to exponential statement. It's a logarithm statement. Now I write here in the right part the exponential statement. The analysis is super easy. You ask by yourself, where's the base? And the first one, 2. What is the exponent? Is the answer for the logarithm negative 5. And what is the result? The result is the number or expression inside the parenthesis, que es the argument of the logarithm. 1 over 32. Okay. Likewise, 3 raised to the negative 5 is equal 1 over 243. And 2 raised to the negative 10 is equal 1 over 1024. Boom. I did number 7, ABC. Are you clear the conversion from logarithmic statement to exponential statement?
Yes.
Yeah. Cool. Let's move it backward. So now in the question 8, we have 3 ABC again, but they are giving the exponential. I need to convert to logarithm. So now I convert to log. LOG, and the corresponding base, of course. The B is 2 to the minus 5 is equal 1 over 32. And 4 to the minus 3 is 1 over 64. Okay, conversion to logarithm, conversion to logarithm. Okay, entonces en the logarithm statement, of course, you need to put mandatory the word LOG. 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 Always. Now you ask by yourself, what is the base in the first one? It's 3. You put 3 here. You enclose in the parenthesis the argument, because I suppose it's the result of the hypothetical no, the given exponential statement, but the answer I know by memory always. This is important piece of information. The answer offered the logarithm statement is the exponent, que es negative. Now this is the base, important piece, base, another important piece, exponent. And the rest is result, que es the number that you put inside here. 1 over 81. Bang! It's okay? So mechanically, 2 parentheses, negative 5, 1 over 32. 4 now is the base, parenthesis, and the exponent is negative 3, and this is 1 over 64. Done. We finish question 7, question 8, and we finish, by the way, the first page of the review package. Everyone follow me? Everyone understand very well? I want every student get 100 points in this test.
Yes, thank you.
No, you deserve. Because it's easy, no? I suppose this is, ¿no? You let me know si es easy o no. So tú dices, no, no, it's horrible. Okay, I never understand this. Okay, number 9. Number 9 is write the simple logarithm with efficiency 1. Okay. So basically what the idea is given 3 statements in numbers 9, A, B, C again. And the thing we are doing is using the property we study, maybe we condensing or expand, depending the question, no? The question say, want to express it as a single is condensing, no? Because we have, for example, 7 logarithm base A of Z minus 5 logarithm base A of W plus 4 logarithm base 8 of B. So you need to know the property number 5 and the property number 6 and the property number 7 can allow us combine each other together, condensing this expression. This is super easy to remember. When you see plus, it's multiplication. When you see minus, it's division. And when you see factor in the front, it's power. So basically, I see everything, plus, minus, and factor, que es 6 points. So I planning that my final answer contain a fraction. The guy in the top is the positive guy. It's Z to the 7 power. So this 7 come from fly. It become like exponent. And another positive B time multiplication time Y time because it's plus. It's plus indicate also multiplication. Property number 5. And the power 4. And division negative is W to the 5th power. And this is the argument of our new logarithm we condense it in only one. Cool? Cool?
Yeah.
B. 1/2 logarithm base 2, no? It's 2. I don't see very well. It's 2. It's 2 of 8. 8 is a variable, no? Minus 1/3 logarithm base 2 of B, another variable, plus 1/5 logarithm base 2 of C. Okay, I got it. It's easy. Let me erase that part. Okay, I have then the condensing is okay. This I don't know. I copied this line. It's no minus. So is you condense it in only one. Remember, we have 1, 2, and 3. No, you condense it in only one. We have fraction. How do you know? Because we have positive and negative. The positive in the top is A raised to the 1/2 multiplication C raised to the 1/5. And B in the denominator que es negative raised to the 1/3. Bam, final answer. Entonces number C es long, pero es easy. Es logaritmo base 5 of x minus, no plus, sorry, logaritmo base 5 of y minus logaritmo base 5 of c. By the way, guys, see the base is different. You see clear that the base is 5, 5, 5, 5, 5, or 2, 2, 2, or 3, 3, 3. See, it's different base. We cannot apply this. We apply another property that we see after, but not now. Plus logarithm base 5 of capital A plus logarithm base 5, wow, too long, of capital B minus, let me make a zoom, logarithm base 5 of C. Okay, you condense it in only one log, base 5. I believe, I suppose, that we have fraction. In the top, you put the guy que es positive, x is positive, multiplication y is positive, multiplication capital A is positive, multiplication capital B is positive. What is the negative, guy? C and C. End the story. Any question? So we apply property 5, property 6, property 7, and both direction. In this case was a condensing. You have several logarithms, 1, 2, 3. In this case, we have 1, 2, 3, 4, 5, 6, and you convert to the only one. So far, no problem. Okay, erase them. Okay, number 10 is similar, but in opposite direction. Opposite direction. Number 10 is, we have option A, que es logaritmo base 2 of something que es 1/16 W6 P3. Entonces, this is easy, but bring me a new complication. Because when this is a variable, you leave it like that. But when this is numerical, you compute this logarithm. So basically, you apply the property number 5 and the property number 7. The property number 5 is the property que expand this problem in logarithm base 2 of 1/16 plus, and now 6 times, because the property number 7, the exponent, you move into the front as a factor, logarithm base 2 again of W plus 3 times, everything is plus because it's time, logarithm base 2 of P. And that's it. Yes, you almost finished, but you need to compute that. To compute that, we can do in 2 different ways, using intuition or using calculator, no? Using intuition is easy because logarithm base 2 of the 1/16, you have no idea what value. I could put x, I don't know. And you convert to exponential. When you convert to exponential, the base is 2. So this small 2 now is a big 2. The exponent is the thing I try to find, and the answer is 1/16. But I know very well that 16 is 2 to the 4th power. And it's a reciprocal is 2 to the -4. Remember, reciprocal, this is important in this chapter. When you flip it, that is -4. Therefore, x is -4. So what is my beautiful final answer? My beautiful final answer is, you replace this by -4. So my final answer is -4 plus 6 times logarithm base 2 of W. So the part is a variable you don't touch. 3 times logarithm base 2 of P. Let me erase this. I enclose in the box this fantastic, beautiful answer. Everyone follow me? Everyone understand very well? Another possibility to compute this is using calculator, using the famous formula, the chain of base. So you suppose that you're using ln of 1/16 divided by ln 2. And you put in the calculator and you get -4. So actually, I convert this non-standard base 2 to a standard. Maybe ln or log, either way. So another student prefer using log. Okay, so you put log in the top and the bottom, we get the same answer. Do you understand? Do you follow me? It's clear?
Yes.
Okay.
So what's in the box would be the final answer?
Yes, that's the answer I need. So you leave it like that. For example, Mr. This is okay, but not 100 points. No total. Or when you see numerical value, you need to compute that. Ah, variable no. Variable because I don't know who is double. Leave like that. Clear?
Yes.
We continue with the 10 because 10 contains 3 parts. What should be similar is logarithm base 3 of 81 a square b6 over c4 d5, fifth power. I expand logarithm base 3 of 81 plus logarithm base 3 of a, and exponent 2 go to the front, these 2, plus again, because we are working in the top part, 6 times logarithm base 3 of b. Okay, now the bottom part is minus. It's a minus 4 logarithm base 3, que is the only base that we have in my problem, of c, minus again 5 logarithm base 3 of d. And one more time happen, you need to compute this. The part is numerical. Es obvio que 4, yeah? Yes or no? Es obvio. So remember the question in the logarithm. What exponent is necessary to raise the base in order to get 81? 81 es 3 to the 4 power. Es obvio que x es 4, pero positive 4, no negative. Entonces my beautiful, nice, final answer would be 4 plus 2 logarithm base 3 of a plus 6 times logarithm base 3 of b minus 4 logarithm base 3 of c minus 5 logarithm base 3 of d. End the story. Please don't forget, numerical part you need to solve. It's a part of the game. Okay, neat. The variable part, no, leave it like that. Any question? We are the best in Miami-Dade College, yes or no? We are together.
Yes, we are.
Yes. Okay. One more, number 10. C. C say logarithm base 5. And we have unfortunately numerical value, 625. X to the 5th, Y to the 6th, Z to the 6th, and W squared. When you expand this only one logarithm and several logarithms, we have this. Plus 5 times logarithm base 5 of x plus 6 times logarithm base 5 of y minus 6 times logarithm base 5 of z minus 2 times logarithm base 5 of w. Okay? Remember, one more time, the guy in the top is positive, the guy in the bottom is negative. Okay, now, computation, this numerical logarithm, very easy. You realize, for example, 5 is the base, this 5 is this. The exponent, no idea, but it's the answer, is 625. And you investigate in your own calculator, multiply 5 times 5 times 5 times 5. So 5 to the 4th power is 625. Because 5 to the 2nd power is 25, no? And 5 to the 2nd power again is 25. And 25 times 25 is 625. Therefore, the answer is 4. Okay, so the only thing that you should do is replace this guy by 4. And that's it. I finish. Any question? No? Cool.
Nope, nope.
Okay. I understand this is. Okay, let's move on to the question 11. The question 11 is about the chain of base formula. Let me recall the famous change of base formula. Is logarithm of the any base, okay, I want to call A is the given base, of the one number or variable I call X is equal logarithm of the another base I want to call B. So we change from A to B. A is the old or given base and B is the new. Okay, I want. Normally the new is standard. Not necessary, but in the majority of the scenario, yes. Of the X divided by logarithm base B of A. This is the formula. Let's apply the formula in each scenario one by one. Logarithm base 12 of 23.5. Suppose que I maybe select in my calculator ln. ln 23.5 divided by ln 12. And they want you round the answer because the answer is irrational, you know. Using 4 decimal places. You put in your own calculator now. ln 23.5, close the parentheses, division, ln again, 12. Close the parentheses, present, bang, yeah, I get the answer. The answer I get in my calculator was, you let me know if I make a mistake, 1.270470, depending on the calculator, some calculator offer more decimal than another, 431. But I need 3. 4, sorry. 1, 2, 3, 4. So you analyze the digit after the 4, okay, 7. If 7 is greater than or equal 5, so you increase it. So it's 1.2705 is my answer. You get the same answer like me or no?
Yes.
Yes.
Okay.
Yes. Yes.
Yes. Please try B and C. B is. Okay. B is logarithm base 5 of 528 using the formula. What formula? That formula. Chain of base. And C problem is logarithm 1/2. If you have some problem with the 1/2, you put 0.5, it's the same, or 44. And now surprise, because something weird happened when the base is less than 1. Let me try. It's ln or whatever, or log, it doesn't matter, of 528, close the parenthesis, division, ln or log, either way, but you put ln in the numerator and the denominator, no, the same. So you know it's crazy. 5. I get the answer. Let me try it next. Somebody get the answer for the first one? Or not yet? No? I get the answer. The answer for the first one is 3.895208.529. But I need only 4. But this digit is 0. Let's take the same. 3.8952. You get the same answer like me or no? Answer me. Yes or no? Nobody follow?
I didn't get the
Yes.
same.
Same? Okay. And the C is minus, the answer was in my calculator. Let me try to understand the logical or illogical this answer. 45.9431619. 19. Wow, what the hell? 19. Now one more time, we need 4 decimal place. 1, 2, 3, and 4. Oh, next digit is 3. It doesn't stay the same. It's minus 5.4594. What's the reason get negative? The reason get negative is clear. Look, when you have perfect matching, when the base, for example, in this example, when the base is 5, gets greater than 1, and the number inside the argument is also greater than 1, both are greater than 1 or less than 1, in this case, both are equal, same behavior, the answer is positive. However, when this different behavior, see, 44 is greater than 1, and 1/2 obviously is less than 1. We have contradiction, that is the reason that we have negative spot. Make sense? Suppose another hypothetical example, you have logarithm base 3, let me use it, logarithm base 3 or 1/3, you see 1/3 is less than 1 and 3 is greater than 1, this is negative 1. Another number that not necessarily is a coincidence, you're using calculator, of course. Clear? Super or no?
Yeah.
Well, let's move now to the complicated part. Always the complicated part is the equations. Equation that contain exponential and logarithm. Some equations, remember, we can solve in without using logarithmic. So we transformation, for example, both sides. For example, number 12 and 13 is the same idea. Look, 13, 12, sorry, first, is 1/3 raised to the 2x plus 5 equal 9 raised to the x plus 3. Classical exponential equation, because the unknown x is located in the exponent part. But you know the 9 is 3 to the 2nd. And you know the 1/3 is 3 to the negative 1, reciprocal. So we can find a common base. Okay, by the way, in this case, 3. 3 is a common base. We take advantage. So now I copy. Not 1/3 anymore. It's 3 to the minus 1 raised to the 2x plus 5 is equal to 3 to the 2nd power, no 9, raised to the x plus 3. Now, one more time, you apply the multiplication. When you have different level of the exponent, you multiply each exponent. This is 3 times negative 2x plus 5. I put a parenthesis because this negative 1 multiply everything. We have binomial here. So you don't put the parenthesis, you are in big trouble, because I suppose you multiply negative 1 only 2. No, multiply the whole thing. Likewise, here is 3 times, 2 times, but no negative positive 2x plus 3. Okay, in this moment, we almost finish, because I can see in this moment we have 2 exponential functions and the base is the same. Therefore, the exponent would be the same. I copy the exponent. So actually, the thing that we are doing is conversion, one original exponential equation. Now we have linear elementary equation. Now distribute the property, minus 2x minus 5. Distribute the property again, 2x plus 6. Solve for x, maybe I bring down negative 5. I move positive 6 to the left, like a minus. 2x stay here, plus 2x. It's a negative 11, and this is 4x. Divided by 4, both sides. X is equal minus 11 over 4. And this is my answer. And you don't need to check anything, because remember, see, you are doing well. The exponential equation give me positive, negative, because the domain of the exponential function is all real number. The logarithmic equation, no. The logarithmic equations are picky and do not accept negative value. Pero the exponential is nice. Super clear?
Yes.
Yes.
Let's move on to the 13, get very, very similar. Mm-hmm. 13 is 1/5 raised to the x plus 2 equal 125 raised to the x. Nice. I know that 125 is 5 cubic. 5 times 5 is 25, and 25 times 5 again is 125. And 1/5 is 5 raised to the negative 1 exponent, reciprocal. You replace 5 to the minus 1 raised to the x plus 2 is equal 5 cubic is equivalent 125 raised to the x. Now multiplication of the exponent, we have 5 minus x plus 2 equal 5 raised to the 3x, 3 times. Again, we have two exponentials, same exponent, therefore the exponent is the same. Minus x plus 2, be careful with the signs. It's important, the sign. You apply distributive properties, minus x minus 2 is equal to 3x. Minus 2 stay. Either way, you're using your imagination. Say 3x plus x, no? Get 4. Minus 2 is equal to 4x divided by 4 both sides. And continue here, x is equal minus 2 over 4. Okay, when you reduce, a lowest term is 1/2. It's important, guys. Never leave an answer like that. The final answer must be reduced in lowest term. Divided by 2, 1. Divided by 2 is 2. It's one possibility, or another possibility is 2 is 2. It's a prime, but I know the 4 is 2 and 2. Therefore, at least 1, 2 is cancelled, and the top is stay negative 1, it's invisible, divided by 2. Same answer. Okay, we finished the page number 2 and the review. Let's move on to the last page. I suppose, okay, today we finish this. But slow down. Let's do it step by step. They are another unbelievable exponential equation. Okay, we cannot express it both sides using common base, like in this example 14. If 5 raised to the x plus 4 is equal to 4 to x. So the mandatory, the only possibility we have is apply logarithm both sides. What kind? I recommend standard, maybe natural or common, either way. Let's use in common, because in another example we use in natural. And you see the beauty of this. It doesn't matter the logarithm you apply, you get the same answer. And you apply logarithm, LOG. Remember, LOG is a logarithm common, base 10, and no specification of the base, and default you suppose que es 10. Of the 5x plus 4 is equal LOG again, 4x. So you apply the property 7, get magic, a sign fiction, and the exponent go all to the front as a factor. I put a parenthesis because it's binomial, no? So in order to don't confuse me, I put a parenthesis. This is time, something, right? Here is similar, but it's just x monomial logarithm. And remember, what is my goal? My goal is x, so for x. So you apply distributive property, you multiply x times logarithm of 5 is just a number, weird number, I know, but it's a number. So it's x times logarithm of 5 plus 4 times logarithm of 5 equal x times logarithm of 4. Okay, let me try to isolate the x. To isolate the x, I recommend moving everything that contains x to the one side, maybe left. So I just bring down these minus x logarithm of 4, and this guy I move to the left like a minus 4 logarithm of 5. Okay, now factor out x, you have logarithm of 5 minus logarithm of 5 equal minus 4 logarithm of 5. We almost finished. I forgot here one parenthesis. In order to solve for x, you divide both sides by this factor. Okay, logarithm of 5 minus logarithm of 4 logarithm of 5 minus logarithm of 4. Entonces x alone is equal minus 4 times logarithm of 5 divided by logarithm of 5 minus logarithm of 4. In this moment, if you want, you can put it in the calculator directly. However, I don't like this because it's too many logarithms. So I propose you, this is optional, you know, condensing, for example, at the top you have logarithm base 5 and exponent is negative 4. You can. Here is subtraction. See, subtraction is logarithm of 5 over 4. So remember, in the top you put the positive, and the bottom you put the negative. And this is much better, in my opinion, no? Well, by the way, 5 power negative 4 is 1 over 65. This is logarithm of 1 over 625 because 625 is 5 to the 4 divided by logarithm of 5 over 4. That's right. Entonces is logarithm, I use an LOG, no LA, it doesn't matter. 1 over 625 division logarithm again of 5 over 4. I get the answer. It's obvious that the answer is negative. Why the answer is negative? Because we are computed, in this case, 026 26976. 4 decimal place, 1, 2, 3, 4. Oh, entonces minus 28.853. 03. Yes. What is the reason? What is the explanation that the answer is negative? Well, okay, answer is negative because this number is less than 1. And logarithm of the number less than 1 is negative, for sure. And this is greater than 1. 5 over 4 is greater than 1. This is the logarithm is positive. and negative divided by positive. It's more complicated, eh?
That's the division.
Say again?
Divided by log of 5 minus log of 4.
You can. Also, some people can don't like this way, the condensing in the last moment. I highly recommend that. You can write like that, mister. Look, you put in your own calculator, minus 4 times logarithm of 5 in the numerator and close in the parentheses. The parentheses is super useful. As you put too much, it's good. No problem. It's like a money, you know, because if you have too much money, it's better, right? So you enclose everything in the numerator and the parentheses, you put division, and another parenthesis, you put log5 minus log4. And close the parenthesis ending in the logarithm of 4, and close the parenthesis que indicate us, que es the expression in the denominator part. Let me try to do it in this way in my calculator. I open the parenthesis. You put minus 4 times logarithmic of 5, no? Yeah. Close the parenthesis, two parentheses, division, open parenthesis, in the denominator, logarithm of 5 minus logarithm of 4, and close two parentheses. One first parenthesis ending logarithm of 4, and one second parenthesis ending the bottom part. Same as. Either way. But, okay. What are the, in my opinion, disadvantage of this? Some students do not respect the order of operation and make a mistake in the answer, right? Because suppose the calculator is a little bit stupid, and you need to indicate exact the order of operation that you need. So you write, for example, without parentheses. So you omit these parentheses. The calculator gets stupid. Compute first that part. And finally subtract. And this is not the computation that I need. I need can you compute separately this guy and this guy. And finally division, right? It's clear the idea or no?
Yes.
Yeah. Very important. To avoid that situation, I highly recommend condensing the logarithm in only one. But it's okay, either way. Okay, 15 now. 15 is another exponential weird in which mandatory you need to apply logarithm on both sides. It's minus x, sorry, it's minus. Equal 5 to x. Okay, so we apply logarithm. Let's apply natural now. Why not? 4/3, 1 minus. Only standard. We have two standards. We have LG and LA. Either way, LM, no M. LM. Okay, LM both sides. Now you apply the property 7. Okay, allow me this exponent go to the front. And magically this new equation is no exponential anymore. It's linear equation. It's obvious that we have weird number. Logarithm of something is irrational number, but it's okay. It's a number. And we compute it using the calculator, and the calculator you compute the approximate answer. No? You apply one more time distributive property. Multiply 1 times logarithm is logarithm. Minus x times logarithm, equal x times logarithm of 5. If my goal is solve for x, I try to move everything that contains x to the one side, maybe right, maybe left. I prefer right in this case, no? plus natural logarithm of 4/3. Now, common factor is x. Inside the new parenthesis, we have logarithm of 5 plus logarithm of 4/3. And this moment, if you want, you can condense in these two logarithms in only one. Why not? Is x times logarithm of multiplication is 20/3. Makes sense, right? 5 times 4 is 20. You multiply 5, que es your whole number, 4, 3, multiplication 20, and 3. Okay, so my final answer would be natural logarithm of 4/3 divided by natural logarithm of 20/3. And unfortunately, don't try to do simplification, nothing here is impossible. This number represent the argument for the logarithm, and there are not any property that you can simplification. And suppose we have no logarithm, okay, cool. Si we have no logarithm, this 3 is cancelled, no? But no, it's totally illegal in this case. Shh, crazy. Calculator now. And you compute, of course, the approximate answer with 4 decimal places. Natural logarithm of 4/3 divided by natural logarithm of 20/3. Boom, I get the answer. The answer is, I copy, is 0.15146414748. Maybe you, in your calculator you get more decimal or less decimal, doesn't matter, but you need 4. See, next digit is less than 5, those stay saying 0.1516. Boom, I finish. Any question? This is 5. This number is 5. We are 5, put it 5. 5, 1. Are you feeling strong in the exponential equation? Yes or no?
Yes.
Yes.
Let's move on to the one more, a little bit weird. It's weird because you have to do some transformation before. Suppose 16, 2 to the 2x plus 2 to the x minus 12. I realize que this is equation que es quadratic in form. What means that? It's an equation in which you are using U substitution. And how do you know? Do you know because this guy have exponent twice, like that? So si yo declaré que you, que es my friend, que help me to simplify this equation, like a 2 to the x. So si yo declaré que this, bueno, this is 12, this is 0, this is equal, this is u, this is twice, this is u squared. Makes sense, right? And in that moment, magically, I have a quadratic equation. Quadratic equation that you can solve using quadratic formula or factorization. I suppose that factorization is good in this case, because the combination that open the door is 4 and 3. 4 times 3 multiplication is 12. I adjust the sign. And 4 minus 3 somehow is 1, because these coefficients. Positive 4 and negative 3. Let me check it out. Positive 4 times negative 3 is negative 12, cool. And positive 4 minus 3 is positive 1. This is the solution. So you separate u plus 4 equals 0. Then u is negative. And u minus 3 equals 0, u is 3. And you split the paper into parts because we don't finish. We found the value of the u, but I need the value of the x, okay, the original variable. So the transformation was, I need to solve for x. However, when I apply the u substitution, I convert the complicated equation in one easy quadratic equation. I solve in the quadratic equation, I have in my hand, in this moment, the u value. But in order to find the x value, one more time, we're using this substitution, but in opposite direction. This u is 2 to the x equal negative 4, and 2 to the x is equal 3. Oh, wow, look at that. This is a stupid equation, because the exponential never is negative. Well, suppose you remember that. So you don't remember, no problem. You apply logarithm of both sides. You immediately see the contradiction. Because logarithm of the negative number is to be undefined. Out of the domain. Error, mistake. Also, this equation have no solution. This part, this piece. The second, yes. The second, yes, because both are positive. You apply logarithm of both sides. You apply the property 7 one more time. Allow me put the exponent in the front. Now x alone is logarithm of 3 divided by logarithm of 2. This is the exact answer, but on this problem, no. I need always the approximate answer using 4 decimal place. I put in my own calculator natural logarithm of 3 divided by natural logarithm of 2. And I make a mistake. Natural logarithm of 3 division, natural logarithm of 2. The answer is 1.5849 62 501. We need 1, 2, 3, and 4. But this digit is important. X greater than 5, increasing. 1.58, 50. 49 plus 1, 50. This is my answer for this equation. Solution is this 1.58, 50. Of course, approximate. So you see what is the exact answer? Well, the exact answer is expressed like a logarithmic, like that. But nobody understands very well what means that. At least quantitative. You know, so it says 20, 40 is small, is big. No, I put in the calculator. Everything okay now?
Professor, and the answer is 1.5850 after rounding it off?
Well, no, because I need one answer that contains 4 decimal places. Entonces, si the last digit is 0, you copy. Okay. So you understand que the digit after the 9 is 6, que is greater than or equal 5. Therefore, you increasing plus 1, the last digit is 9 plus 1 is 10. So actually, it's not 49, it's 50. Makes sense, no? Is your question or what's your question? Miss?
It was that exactly. Thank you for clarifying.
Okay, let's move on now to the logarithmic equation. Logarithmic equation is picky because remember the logarithmic the domain is only positive value, no negative, no zero. Logarithm zero undefined, logarithm negative undefined, illegal. Therefore, when you manipulate the equation, if you get solution negative, I suppose it doesn't work. So you try to take it only the positive solution. So let's do in 17, is logarithm base 4 of x minus 7 plus logarithm base 4 of x minus 7 equal 1. Look like we are, because they are twin brothers, right? Yes or no? Twin brothers, twin brothers. This guy and this guy is the same. There are two possibilities, or you put twice each other, like a combined letter. Or I prefer apply the property number 6, que es the multiplication, and you have logarithm base 4 of the x minus 7 times is 7, que es square. Okay. In this moment, I condensing two logarithms and only one. And when it's only one, it's easy. Because now, what is the next step? Conversion to exponential. And you put in the test something like that. Arrow, and you indicate to exponential. I understand very well the action that we are doing. You convert to exponential. This logarithm statement, you convert to exponential in order to see more clear. The base is 4. The exponent es obvio que es 1, que es invisible, by the way. And the answer is x minus 7 squared. Nice. I like that. And in this moment, we have a quadratic equation. Okay, by the way, somebody do me a favor, que es factorization. Entonces now you apply square root both sides. Square power and square root cancel out each other. And this is square root 4 gets plus and minus 2. Don't forget plus and minus. Square root 4 is 2, but you put plus and minus. Now, solution R. X equals 7 plus and minus 2. No? I move 7, que negative, to the right hand side like a positive. Actually, we have two solutions, the 7 plus 2. And we have another solution, the 7 minus 2. Solution is 9, and solution is 5. And you need to decide if both solutions is true or no. I suppose que 9 is good. Why? Because 9 minus 7 is positive. However, 5 no, because 5 minus 7 is negative. And this is no. Therefore, the only solution that we have in this problem is 9. You follow me?
Yes.
Be careful with the logarithm. They are picky. So you get the answer, not necessarily to be negative for don't work. So you plug it in this value gets given in the original, and you verify que undefined or no. Si es negative, the argument of the logarithm obviously doesn't work. Okay. Now 18 say logarithm of x plus 3 is equal to 1 minus logarithm of x, and so for x. Oh, but I am confusing, Professor, because you don't specification here the base. So what is the reason I do not specify? Oh, no, I do not know. I copy in this review. No? What is the interpretation of this? When there's no specification of the base, what is the number? Default. Huh? You don't remember? Nobody remember that. Remember, we have two standards. We have standard and non-standard, no? Logarithmic. What is non-standard? Logarithm base 2, logarithm base 3, pero we have two standard, que es logarithm base 10 Okay, the symbolic way to indicate this is you put log, non-specification, the base, everyone in the world understands the base is 10. And when the base is E, que es natural, is LN. It's the symbolic way to indicate que the base is. Do you remember this or no?
Yeah.
Therefore, when you see that problem, que no specification the base, immediately you say, wow, the professor put the example of the common logarithm, base 10. Okay? Now what should I do? Well, you try to manipulate the equation in order to express it both logarithms in the same side. Because in one moment I need to condense in them. I copy this, I copy that, put it to the left, positive, and stay only one in the right hand side. Now ready to apply property 5. Property 5 say when you have 2, 3, 4, 5 logarithm, you multiply the argument. It's x times x plus 3. Something like that, equal 1. Okay, now we have one single logarithm. Cool. Now you convert to exponential to understand more clear. But this is a moment in which I need to know that the base is 10. So this 10 gets invisible. Now it's visible. The exponent is 1, que is invisible. This one is invisible here. Equal, x plus 3. Oh, easy equation. This equation, I suppose, a quadratic equation. Let me copy again. 10 equal x times x plus 3. You apply distributive property. X squared plus 3x. Entonces, quadratic equation. Y I put in the standard form of the quadratic equation. Que is x squared plus 3x minus 10 equal to 0. I suppose que it's possible by factorization. The combination, I suppose que 5 and 2, no? 5 times 2 is 10, 5 minus 2 is 3, positive 5 and negative 2. One solution is negative 5, and one solution is positive 2. Okay, and I need to check it, as always. Negative 5 doesn't work, because negative 5 here plus 3 is obvious que es negative 2, and logarithm of negative 2 do not exist. So the solution, this doesn't work. And 2 maybe, I don't know. Let me check it just in case. How are you checking? Plug it in the original. And the original say, I need to verify the logarithm of 2 plus 3. So you should replace x for 2. Should be equal, I claim that, I'm not sure if it's true. 1 minus logarithm of 2. 2 plus 3 is 5. This is easy. How you manipulate to verify that this statement is true? Well, similar idea I did here. You move logarithm 2 to the left, plus you apply one more time the property number 5. This is 5, and you condense in only 1. The multiplication 5 times 2 is 10. Wow! And I know that the base default is 10. Yeah, I know very well that when they are perfect coincidence between the base and the argument, it's obligate 1. Okay, and this answer is perfect. Super cool.
Yeah.
Let's do in the last one. It's 19. 19 look like a little bit crazy. But let's try to do our best. Okay. This logarithmic 19. Logarithmic of 2x plus 1 equal 1 plus something. Logarithm of x minus 2. Again, one more time happen. Que no specification the base. Therefore, what is the base in this problem?
10.
10. Very well. Now I try to do my best. My best is try to move the logarithm of the same side because I know in one moment I need to condense it in only one. This stay the same. I don't touch. But this, yes, I put like a minus in the left hand side. And you apply the property 6 because it's the subtraction property. Entonces, logarithm of division, 2x plus 1 in the top, x minus 2 in the bottom, equal 1. Clear?
Yes.
Now, what should I do? What should I do always? Conversion to exponential to see more clear. And the base, you need to know is 10. 10 to the 1 power is invisible 1. Equal. The rest is 2x plus 1 divided by x minus 2. Entonces, I focus 100% in the solution for this equation, que es, in my opinion, no big deal. 2x plus 1 over x minus 2 equal 10. Okay, why not? Cross multiply. Multiply this and this, multiply this and this. This is 2x plus 1 times 1. 1 is invisible, multiplier, 10 times x minus 2. Okay, cool. So now distributing. 2x plus 1 equal 10x minus 20. Okay, let me try to do my best. Therefore, 1 stay here plus 20. I move 20 to the left. 10x stay in the right hand side minus 2x. This is 21 and this is ax. Divided by a both sides. Solution is x equal 21 over 8. Wow, it's weird. I need to verify, but at least it's positive. Si es negative, automatic, I discard. I need to verify this. How you verify that? Plugging 21 over 8 into the original equation. It's doing logarithm of 2 times 21 over 8. So you replace x here for the famous 21 over 8 plus 1 should be claimed that I'm not sure if it's true. 1 plus logarithm of 21 over 8 minus 2. Okay. Well, I try to manipulate here inside. Oh, I see that divided by 2, 1 divided by 2 is 4. Now, actually, we have 21 over 4 plus 1. So I just copy so far that part. I forgot temporary LOG because I want to focus in the addition to fraction. Okay, always is a little bit complicated. Well, we can put it in the calculator if you want, but no, let's do it by hand. Look, least common denominator is 4, and we have 21 plus 4. And 21 plus 4 is 25 over 4. Okay, cool, I like. And so far we have logarithm of 25 over 4 in the left hand side. In the right hand side, we have 1 plus something. Oh, but it's 21 over 8 minus 2. 2 is a whole number again. And the least common denominator is 8. It's 21 minus 16, no? Welcome from 16 is 8 times 2, no? 16. This is subtraction of 5 over 8. Yeah, F5. This is LOG of 5 over 8. How you prove that this is true? Well, you're using the same idea of this. Look, The idea is you move this logarithm to the same side and try to condense it. Logarithm of 25 over 4 minus logarithm of 5 over 8 should be 1. Now, one more time, you apply the property 6. Okay, help me to condense this logarithm only 1. But this is division. Division who? Division 25 over 4 divided by 5 over 8. Should be 1. Whoosh. How you prove that? Easy. Easy because you are doing division. Remember division, I isolate the 25 over 4 divided by 5 over 8. You copy the numerator part, gets 25 over 4 time and flip it up, 8 over 5. Multiplication, you change this division to multiplication and flip it the second part. It's relatively easy because you divide by 5 1, you divide by 5 5, and 8 and 4 divided by 4 is 1, divided by 4 is 2, and 5 times 2 is 10 over 1, que es invisible. Actually, ya I discovered que that part is equivalent to say log of 10 is equal 1, que obviously this is true statement, because one more time happen when you have perfect coincidence between the number and the base, que es 10, and the number of the argument is 1. Okay. Therefore, the answer 21 over 8 is weird, but it's good. How do you feel for that test? Remember, you solving, you solving by piece of paper, somehow take a picture or a scan. The scan, you have a scanner or you have application in the smartphone. Okay, when you take a picture, convert to a scanner, to PDF, sorry. And you send me Monday at midnight. I will grade Tuesday in the morning. Cool, guys? No problema.
I have a question.
Go ahead.
The graph, do you want it on the website of the last one, or we can do it by hand?
No, the last one.
Like on the website?
Yeah, and the website in Canvas. For example, in the reading test, you have perfect score at 100. Plus 5 points extra of the YouTube is 505. I suppose everyone subscribing the YouTube, no? I check it, bro. And this is a reading test. In the online test, you have a score 100, but remember the homework. The homework included 10 extra points. And you need to get the 10 extra S because you get in any homework a score greater than or equal 80. So you got 79? No. And you have 110. And this is the number I put in the Canvas.
Okay.
How we compute, Miss, the overall grade in the last moment? You find everything. You have, actually, we have 5 written tests, 5 online tests, and you summation, everything, okay, actually is 10, no? 10 1, reading, 10 1 online, 10, no? Divided by 10, average, and you get the score. Okay, and the score, actually, I convert to letter, no? And say when it's greater than 90 or equal, it's A or B or C, D. And remember that you can use in the help of the final test. Final test totally optional. It's not for everyone. So si some students need to improve, take the final. The final I say in the last day. The last day, no, the last day of lectures. Yeah, I collect the last day of the subject. Your question was clarified, Miss?
My question was for this exam on the graph. Do you want it on the website that we did the ones on the last exam, or you want it on the paper that we graph it ourselves?
I posted both.
Okay.
I call reading or no. I call test on paper and test online. I posted both.
Okay. Thank you.
Okay, please Could you, everyone need to check in, si my score que I posting is right or wrong. Si something is wrong, si you have discrepancy, something wrong, you communicate with me by email. Entonces, si I understand que I make a mistake, I fix it. Okay? Okay?
Okay. Okay, thank
Okay,
you.
cool. Bye-bye, guys. See you.
Thank you,
Good night.
Professor.